graders, today's assignment is pHet, gravity, and orbits. Obviously, if you guys are watching this, you guys are either at home doing this because you were absent, or I am gone today, and you guys are doing it in class with a guest teacher. So with that being said, you guys should have taken about the first 15 minutes to finish up yesterday's Your Weight on Other Worlds activity. If you guys did not finish that, remember that we will have some time later this week and possibly at the end of this class to come back and work on that. So with that being said, put that assignment away. It's done. We're going to focus in on today's assignment, which again is pHet, gravity, and orbits. Today, your learning targets, I can describe how the mass of an object affects the gravitational force of that object. So first thing you guys need to do is on slide 2, and we're going to add a little bit into our notebook. So this is a new unit, so you guys will need to create a new section. So open up your OneNote. Again, new unit, so we're going to add a new section and title it Gravity. So you guys can go down here, click Add Section. You're going to retitle that section Gravity. And then you guys are going to add one page. You guys should have a total of 2 pages now. You guys are going to title the first one Mass versus Weight. And you guys are going to title the second page Gravity. With that being said, your guys' notes you add today are going to be under mass versus weight. So go ahead and copy and paste this little section of notes that we kind of focused on in your Weight on Other Worlds. So what we learned yesterday is that mass is the amount of matter in an object. So if you guys think of all the atoms and molecules, that's the matter, okay? And that doesn't change no matter where we're at or what the gravity looks like. Weight, on the other hand, is the amount of force on an object due to gravity. So we calculate weight by taking the mass of that object and multiplying it by its gravitational force. So if we're talking about the gravitational force on Earth, that's about 9.81. However, if we compare it to the moon, that's about 1.62. So it's quite a bit smaller on the moon, but the moon does still have a gravitational force. That being said, you would weigh less on the moon. Okay, and again, weight changes with gravity, so the less gravity you have, the less weight you have, or the lower the weight. Okay, the more gravity you have, the more weight you have. Okay, so you guys should go ahead, take a minute, pause this video, take about 2-3 minutes to add in this section in your notebook. And once you guys are all done, please flip your computers back towards the front so you guys are ready to pay attention and move on to the next part of this. Okay? All right, so for the rest of this, I'm just going to explain through it, go through it, and then you guys will have the rest of the class to work on this. Again, it really shouldn't take you guys more than about 20 minutes, so if you guys have time after you're done with this, okay, you guys need to go back and work on yesterday's Your Weight on Other Worlds, or you guys will need to do this either in advisor or for homework if you don't finish up in class. Okay, with that being said, your guys' link for today's assignment is right here. You guys will open that link up. You guys will choose Model. You guys will make sure you check all 4 of these boxes each time you run this, and you guys will then go ahead and hit play and observe what happens. Okay, so let's go ahead and move on to slide 4. First question asks you guys, after you hit play, what did you notice? Again, at this point, all your guys' laptops should be facing forward so you guys are paying attention. Okay, you guys will hit play and observe what happens. These grid lines are really nice because they show you guys specifically where your guys' orbit goes, and if it changes at all, you guys can kind of compare to the line that was drawn in the grid lines and whatnot. Okay, a little change of colors. This arrow used to be red, so I'm going to have to fix a couple things with that. So after you hit play, what did you notice? Okay, what does the green arrow represent? If gravity did not exist, what would that green arrow tell you? So this is all in there for you guys. You guys can see kind of your little key over here. Here's your green arrow. So what does that tell you, and what does that arrow represent if there were no gravity? If you guys are not sure, turn off your gravity and see what happens, okay? So that's your kind of first little couple questions for you guys. Pretty simple. As the planet is still moving, change either the planet's mass, the star's mass, or both. Highlight what you guys changed. If you guys changed multiple things, make sure you guys circle whatever you did change. So you guys can either make the star's mass greater, the star's mass smaller, or you can make the planet's mass greater or the planet's mass smaller. Okay, again, circle whatever you guys did, and then tell me what happened. You guys are basically going to do this 3 times. So next slide tells you guys, all right, click reset, recheck all your boxes. Okay, so make sure all these 4 boxes are clear, and then you guys are going to try something different. So again, change either the star's mass, the planet's mass, or both. Circle that you guys changed. It should look different than slide 5. And then tell me what happened. Okay? You guys are going to do that one more time. Okay, click reset, recheck all the boxes, and change either the planet's mass, the star's mass, or both. Again, highlight all that you guys changed. It should look different than the last 2 slides. Okay, tell me what happened to your orbit. Okay, in one of those, you guys should have made at least 2 things happen. One thing that you guys should have been able to do is make that little planet leave the orbit. Okay, second thing you guys should have been able to do is make that little planet crash into the sun. Okay, so were you able to have the planet leave the orbit of the stars? You guys are going to answer yes or no. Okay, if you guys answer no to that, you need to go back and try to make this happen. Okay, what changed? If you guys chose no above, get this to happen. So make that planet leave the orbit of the star. Okay, and then circle everything that you were able to do to get it to leave. It might have just been one thing, or maybe it was multiple things that allowed that little planet to kind of drift away from the star. Okay. Vice versa, were you guys able to have the planet crash into the star? So again, yes or no. If you guys answered no on that, go back and make it happen. Figure out what you guys have to do to make that happen, and let me know, what did you guys do to make that happen? Okay. Finally, click the reset button, recheck the boxes, and now we're going to add a moon, and we're going to kind of look at how the moon orbits with that. So you guys will click here. So you guys can see the little purple represents the orbit of the moon. Okay, and then the gray is still the orbit of that planet. Okay, so you guys can see how the moon rotates around the planet, what that kind of looks like, and then you guys can see how that planet rotates around the sun. Okay, click play, what happened to the planet's orbit, and what does the moon's orbit look like? So again, look at the gray to answer that first question, and then look at the little purple to answer the moon's orbit question. Okay, click reset, recheck the boxes, keep your moon on there. So you guys basically are resetting this. I think you guys can just click right here to reset as well. So you guys still have your moon there. All my boxes are clicked. Okay, change either the planet's mass or the star's mass or both. So basically similar to what you guys did above, but now we're gonna see how a moon kind of takes effect in this. So circle everything that you changed and what happened to the moon and the planet's orbit. So check out what happened to the moon. Did anything happen there? And what also happened to the planet. So you guys have already kind of explored a little bit about what happens with the planet. Okay, last little section here, and then you guys have some questions to answer. Play around with these 2 options. So you guys are just gonna look at the planet and the moon. So our center of our little orbit here is just the planet. Okay, and then also the planet and a satellite. What happened pretty quickly in each sim compared to the previous experiment? So previously we looked at how the planet rotated around the sun, okay? We're looking now at how the moon rotates around the planet and how the satellite rotates around the planet. So what happened a lot faster in these 2 than you guys saw when we were just looking at the planet moving around the sun, okay? Hint, look at the elapsed time of Earth day. So keep this in mind here. Okay, what's happening quicker than when we looked at our planet rotating around the sun? Okay, all right, answer that question. What happened to the amount of gravity as the planetary object's masses increased? So if you guys were to increase either the sun or the mass, what happened to the amount of gravity? And then what evidence do you have to support this? So look back at some of those specific examples and tell me what you guys saw when you changed by increasing the amount of mass that either the planet or the sun had. Okay, so give me some specific evidence there. Other than mass, what factor also changed when you compared the orbit of the Earth around the sun to the orbit of the moon around the Earth? Okay, so think about the difference between the Earth and the sun and the Earth and the moon. Earth and the sun, Earth and the moon. Okay, so other than the mass and the gravity, what else changed? Okay, how did that affect your gravity? And what evidence do you have to support this? Again, where do you guys see this happening? What's different about it? Think about what you guys see in that. Okay, and that concludes this assignment for today. So when you guys are done, you can hand that in. If you guys have not finished already, you guys can turn around and go back to your Wait on Other Worlds once this assignment is done. Okay. If not, you guys can show the guest teacher that you are done with both assignments, and you may have free times, but they need to be able to go in and look at your whole assignment, not just the part where you guys hit turn in. Okay, so if you guys want free time, you guys need to prove that to your guest teacher, and I hope you guys are having a good day. Please work hard and stay in your assigned seats. Thanks, bye.